What's up, guys? Yesterday I sent you part one. This is part two. What's more important? Again, yesterday I told you lightly that what is the importance of watching yesterday's video. That all the three derivations are important, and that height or depth, one of them will for sure be asked. All those things are there. Today's concept will be asked in two forms. One is in terms of regular gravitation. Questions, or in terms of numericals, or in terms of MCQs, or in terms of CET questions. Okay, this has some concept actually. We'll see. So basically, first one is gravitational field. Now, first of all, I'll explain the meaning of field. Okay. Field, the best word to explain is influence in our language. So let's say the moment you guys switch on the Wi-Fi, okay, at home, let's say the Wi-Fi router is at the ground floor. If the Wi-Fi is strong enough, it will be felt even it will be experienced, or the connection will be strong even in the first floor, which means the field of that specific Wi-Fi router was up till one floor, or was up till two floors, or was up till three floors. Simple language. I'll take school examples also. If I tell Baldwin boys, if I tell Bishop Cotton boys, all these things, the name is known up to, let's say, 10 kilometers area. Example. So to the up to the next 10 kilometers, everybody knows the name about all these two or three schools, also called as ICIC schools. So that is the field of the school. Fine. That's the influence of the school. So the best word to define field is nothing but influence. Now, what is it to do with gravitational field? Understand, gravity also is going to have some kind of radius. That gravitational pull also will be experienced up to some kind of radius. How much or what is it is what we're trying to learn right now. In today's class, we will be solving one of the concepts where a little bit of integration will be involved. Nothing to worry. Fine. Nothing to worry. But gravitational field, that's the meaning of it. Without learning this gravitational field, the next concept which can appear as a derivation cannot be explained. So gravitational field is important only in terms of definition. I'll send the notes for it. But in terms of derivation, what is important here is gravitational potential energy. This is what is important in terms of derivations. Okay. To solve this, I'll have to require a gravitational field. Now, please focus as to how I will start off with. I will start off with whatever we learned in yesterday's class. Is just that I'll be changing few names here. Okay, few names. First, I'll derive, then I'll draw the diagram. It is usually the other way around. Even I don't like this method, but because this involves integration, this was the thing I was talking about. Because this involves integration, and you guys do not know the complete formulas of integration. If I draw the diagram first and then explain, no, it'll be kind of going over the head. So I'll derive first and then explain, then draw the diagram. Okay. How should you remember it? That is completely your wish. So how do we start off? Yesterday's concept, I write F is equal to G. I wrote M, no, same thing. I write M, I write caps M, whole thing divided by, yesterday I wrote R square. Today, I'll change that. I'll write X square. So compared to yesterday and today's class, what is the only thing which I'm trying to change? I'm changing all the R's in terms of X. Now, why is it the scene? I'll tell you. Fine. Now, please focus. In the next concept, what I'm trying to tell you is, we are potential energy. If you see the other day also, we tried in the chapter work per energy. We realized that potential energy, kinetic energy, all these things boils down to some kind of work done. So in order for me to find the potential energy, I'm supposed to find the work done. Work done according to us till now is given by just one formula. It's nothing but F into S. Okay. Observe one thing properly. F means force, cool. S means some sort of displacement. Come back to this concept of F here. Here, displacement or distance is nothing but some kind of length. Don't you think the denominator also represents some kind of length here? Correct? Because X meaning, or R mean, X meaning radius. Cool. What is radius? Radius is also some sort of length. So what I'm trying to do, I realized that in my formula W is equal to F into S, and in the formula which I wrote right now on the board, both of them are talking about length itself. In order to make both of them the same, I'll convert the F into S as F into X. Okay, F into X. Now, what's going to happen? Just imagine a small concept here. Let me draw a circle. If I draw a circle, if you see, this is actually a dotted circle. To be more precise, if when I'm using the word circle, a part of the circle is called as a curve. Okay. So let's say for my experiment, I'm only going to consider this part of the curve. The remaining everything is ignored. The reason I'm going to ignore this is because I'll perform my complete experiment only on a part of the curve. Okay. Once I get my clarity, once I get my complete answer for the part of the curve, don't you think circle is nothing but multiple parts of the same curve? The same curve multiple times. Okay. So it's because I know this, I'll experiment only on a part of the curve. part of the curve. Okay. Now, the complete curve is going to have some radius called as x. Think for a second. If the complete curve has the radius x, don't you think the part of the curve will be called as dx? Dx meaning a small part of the curve. Again, we are trying to involve differentiation as well as integration here. So what's the change till now? W is equal to f into x is for the complete curve. But I'll be performing my experiment only on a part of the curve. Therefore, what I focus on is not complete x, it's only dx. So for me, more than w equal to f into x, I like f dot dx. This is what is important for me. Fine. Now focus. I will go back to my regular concept of gravitation here. I hope you guys got this, or else just rewind the past 5 seconds to 10 seconds and rewatch it. It's the same concept. Now, what I realized here is when I'm performing my experiment on a part of the curve, it only takes a part of my work, not complete work. So more than W, dW makes more sense. It's like for me to give money to 100 people, I need more money. For me to give money to one person, I need less amount of money. So first I'll figure out how much I should give to one person by giving less amount of money, which means it is less burden on my side. It is less burden on the takers. On everything basically. So experiment was conducted on a part of a curve, therefore dx. So since I'm performing on dx, the work required from my end also is not so much. Therefore, it becomes dw. What I'm going to do, I'll write both the things here. So I'll write work done is equal to, don't write the first one because I'm performing the experiment only on a part of the curve. I'll write dw is equal to f into dx. Now I'll tell you what are the common mistakes. They'll be like, sir, you are applying, you're performing work only on a part of the curve. Why are you applying full force? Again, what I'm supposed to pay back is money only, no? Just because I'm paying to one person, can I have a discount with him? Telling, hey, bro, I'm just paying, I just have money to pay you. So can I pay less? Doesn't matter. What you're paying is money. The stress on your side, because the number of people were less to cater, it is your side, you have less stress. But end of the day, you should think from the other person's side also. If it is money which you're supposed to own, you will give the same money. You won't tell, bro, I'll give you a part of money right now. But the logic is how it works. So the force remains the same. The part which you guys are working on will keep differing. Now, don't you think once you write the work done, it becomes actually very simple for us? So this is step number one. Step number two, I get here. Write the dw as it is. Don't write f. Instead of f, we have an answer. No. What is it? G m caps m whole thing divided by x square dot dx. I hope you guys realize as to why I assumed x everywhere. Dx and x, both of them are matching. I wanted them to match. Now we know a few rules in integration as well as differentiation. The rules goes like this. Whatever is a constant, I'm supposed to start taking them outside. Those are the rules for both integration as well as differentiation. Now, understand, you're working out on a small piece of curve or small piece of a circle, which means you should always integrate later. So what I want the complete work done. I don't care. I want the complete work done. You do your experiment on a part of the curve, full curve. I actually don't care. I want the complete work done. So how do you convert dw into w? How do you convert part work into complete work? By integrating. Simple. So next step, we'll write w is equal to integration of dw. Okay, dw. Now, please focus for the next 10 seconds. Very important explanation here. We always learned in 10th standard that potential energy is, the definition is nothing but the amount of work done to bring a charge from infinity up to a point. I'll repeat that. From infinity up to a point. Same thing. From infinity up to a point R. Okay. Up to a point, meaning that point is going to have some radius. So, sorry, that length will be represented by R here. I hope you guys don't get confused because I'm bringing R into picture here, not in the F formula. I'll repeat it. So you write, complete work is equal to integration of these smaller works. From where to where? I don't know. Go back to the question. Question says potential energy. Potential energy is always from infinity up to one point. Infinity up to one point. You're right. We are done with it. Now what I'm going to do, I'll write W as it is, integration as it is. Now don't worry as to how to solve this. Looks complicated, that's all. I'll teach how to solve. Write the same infinity, write the same R. Instead of writing dw, we know the answer for dw right now. Copy the same thing to be get rid of. So you write G m whole thing divided by x square dot dx. Now what can be done? Keep the w. Just now I told you one rule. Bring all the constants outside. Okay. How do we bring the constants outside? Write all G, M, and ME. So basically, G is a constant, M is a constant, caps M is also a constant. What and all is remaining? That sign is remaining. Below infinity is remaining, r is remaining. Inside the bracket, 1 by x square is remaining, dot dx is remaining. So you brought all the, what do you call, the constants outside. We are almost done with the answer. Now, I'm supposed to integrate. Always remember, the answer for this, you should mug up basically. Integration of 1 by x square dot dx, okay, is equal to minus 1 by x. This is the formula. Can't, you should remember. Fine. Is equal to minus 1 by x. That's all. Now, what you'll do, the next step, keep the w as it is. Write the g, m, m as it is. Instead of writing that symbol, no, you don't draw the symbol, draw square brackets. And inside the square brackets, write the answer. What's the answer? Integration of 1 by x square is nothing but minus 1 by x. Instead of writing minus 1 by x inside the bracket, I'll put the minus here. It's easier for me. I'll only write the 1 by x outside. What was there below? Infinity was there, r was there. Whatever was there at top at bottom, no, I just copy paste it right and left. That's all. Fine. I'll repeat this. Integration was there. So I'll have to get the answer. Integration of 1 by x was nothing but minus 1 by x. I flip there. Minus I put it outside. G, m, and m all were constants. It's anyways outside. Integration of answer is 1 by x from infinity to r. That's how it works. Now, keep the w as it is, minus as it is, g as it is, m as it is, m as it is. Now, please focus. This, you can't ignore both infinity and r. I'll teach you a trick right now how to solve. Always understand, in your final answer, you do not want x. You only want in terms of r. So the actual method is you're supposed to substitute. Take the top value, put instead of x. Take the bottom value, put instead of x. So I'll write 1 as it is. Instead of writing x, what's the top value? Substitute that. Becomes r. Always a minus. Always. 1 by infinity. The problem here is 1 by infinity's answer is 0. So in the next step, what I'll do, it becomes minus g, m, 1 by r minus 0. It becomes 1 by r minus 0 is anyways 1 by r. So the final answer is w is equal to minus g, m, whole thing divided by r. Okay. Now, during this case, in this case, the w is nothing but potential energy. Potential energy is represented by u. So u will be equal to minus g, m by r. That's all. So just copy the same thing. Fine. Because potential energy is also some kind of work. I'll repeat from this part. We write dx, then we take out the constants, because that's the rule in integration. All the constants came outside. Why is it infinity to r? I told you based on the definition. 1 by x squared dot dx as it is. This is the integration formula. It's right there. Answer is minus 1 by x. Since we solved the integration, we only put brackets and put 1 by x, send the minus outside from infinity to r, done. Minus, write everything. Wherever there is x, substitute for both the answers. And you'll get the answer as r and 1 by r minus 1 by infinity. 1 by infinity is nothing but 0. 1 by r remains as it is. Regular thing. Once you get the answer, the answer will be u is equal to minus g mm by r. This is the meaning of potential energy. That's it. Fine. Will it come? 100% it will come. Next concept. Next concept is called as escape speed. Very super duper important for definition also. Definition, the book I'll send you, in the definition in the, what do you call, the PDF. But meaning I'll tell you right now. So basically, understand, Earth's surface is there. Okay, Earth's surface. A surface. Just imagine like satellites. For the satellite or the rockets, when they leave the Earth's surface, no. For them to leave the Earth's surface, they have to go, minimum speed. That minimum speed required, I'll repeat that, the minimum speed required for an object to be projected from the Earth's surface so that it easily escapes the Earth's gravitational pull. In other language, inside Earth, there is completely there's gravity. I should throw an object in so much speed that it should be able to escape the gravitational pull and go outside the surface and do not come back. Okay, so that minimum speed required in order to escape from the Earth's gravitational field is called as escape speed. I'll repeat that. The minimum speed required to escape the Earth's gravitational pull is called as escape speed. Into the atmosphere, basically. Now, how do we start off with getting the answer? Very simple. We use U also here. We use U, potential energy here. Now, in this case, R means radius of the Earth and all those things is completely fine. So we write U is equal to minus G m by r. R meaning radius of the earth, basically. Okay, here I'll let me because mass of the earth, and r is radius of the earth. Now, we also know that kinetic energy. Kinetic energy is given by half mv square. I'll let half mv square. But little careful I'll be. I'll let ve. Okay. Even if you don't write v, it's completely fine. I'll just write ve. Now, what is the only thing you're supposed to remember? So this is equation number one, equation number two. If you see, equation number one is potential energy. Equation number two is what do you call kinetic energy. Now, please understand, how do you, for us to get the answer, the kinetic energy should always be equal to zero. Fine. That's one of the ways of doing it. Okay, that's one of the ways of doing it. Or else, remember it in this way. The total energy should be equal to zero. This is the condition which is based on escape speed. Only remember this. Total energy should be equal to zero. But we also know the total energy is given by the formula kinetic energy plus potential energy. Correct? We will apply this. How do you know this? Regular previous chapters. Now, I'll write total energy as it is. I know it should be equal to zero, but I also know the formula. Instead of writing Ke, I'll write half mv square. Half mv e square minus, you might wonder, sir, there's a plus here, why minus? Look at this. There's a plus here, but u has a minus. That's why it's a minus totally, plus into minus. Minus g m m by r, write e and e. Fine. So you wrote both of them. Now what can be done? Left hand side t is value we know. What condition will it, is it, will it escape? At 0. So left hand side becomes 0. 0 is equal to, copy paste that. Half mve square minus gmme by re. Common sense. Put the minus to the other, send the minus things to the other side. What will it become? It become plus. So it becomes gmme whole thing divided by re is equal to half mve square. Now, 2 crisscross becomes, oh guys, 1 second. Before crisscrossing, 1 second. That's correct. There's nothing wrong. Now I realize I can cancel m and m. Okay. What am I supposed to find? I'm supposed to find ve. That's all. Okay. So keep the ve square on the right hand side. M and m gets cancelled. 2 shift. So it becomes 2. 8 cap g as it is. Lowercase m got cancelled. Me remains as it is. Whole thing divided by re. This is almost my answer. The reason I can't stop here is because the right hand side has square on top of it. It's very simple now. So keep the ve as it is. Whole thing root of 2gme by re. If you observe here, this answer is in terms of caps g, which means constant. They'll also ask you, what is the, derive the same escape speed, until here you should do in terms of lowercase g. Okay, in terms of lowercase g. How do you do? Very simple. We know from yesterday's concept, g is equal to gme by r square, re square. Correct. So if you focus, almost everything is matching here. One extra r is there. That too where? In the denominator. Okay, that too where? In the denominator. So that's one way of solving it. Or that's one way of solving it. Or directly get, or listen up. I'll tell you another easy method basically. So VE is equal to, put brackets because of the square brackets. Copy the 2 also as it is. Okay, copy the 2 also as it is. This is the trick to remember. What was extra in lowercase g and your answer RE was extra, correct? Write that RE in the numerator. That's a trick basically. So you look at your answer. For what answer? VE, final answer. Root you copy paste as it is. 2 you copy paste as it is. Now you compare GME was by RE was already there. G lowercase g meaning GME by RE square. Okay, there's a problem there. So you'll realize what is extra. Extra was RE. Whatever is extra, put in the numerator. And blindly write a lowercase g. This is your answer. They'll give you marks. Fine. So I'll repeat that. Till here is the answer. By chance, they expect you to keep the answer in terms of lowercase g also. Root as it is, 2 as it is. GME by RE is almost matching. What is extra? RE is extra. Write the RE in the numerator. When? Why? It was extra. Then we were supposed to convert in terms of lowercase g. Write that also. This is my answer. This is in terms of acceleration due to gravity, the second formula. The first one is in terms of gravitational constant. That's all. Fine. Now, next concept is about the Earth satellite. Don't get confused. Right now, what I spoke about is escape speed. It has to go away from the Earth's surface. For example, if I throw a ball, I'll have to throw a ball with some speed in such a way that it should not come back to the Earth. Fine. So that speed is nothing but escape speed. But once, let's say satellite, the satellite will keep on rotating, no? I mean, or will get settled at least, where outside. Wherever once an object is there in the atmosphere, we allow that'll keep traveling, that will travel with some speed. That speed will be called as orbital velocity. Orbits are not inside the earth, guys, understand? Fine. Orbital velocity is always outside the earth. How do you define it? Very simple. The speed of the satellite in a circular orbit, just like a, I mean, orbit, the satellite also will keep on moving like this from left to right or right to left, depending on our wish. It will travel with some speed. That speed with which it travels is called as orbital velocity. Why orbit? Because why orbital? Because it is traveling in the same orbit. Why velocity? Because it's some sort of speed. How do we get this? Understand one small concept. It's very simple actually. We use again two things. First is we learned the formula for centripetal force. I'm not sure when, but I think 10th standard. Centripetal force was given by, understand, mv square by r. Okay, this is a formula which we learned in 10th standard. Now concept here is, this is the Earth's surface. Imagine. Sir, let's say satellite. Satellite will be somewhere here in the dotted line. Correct. This is where the satellite is. So if you see, the distance between the satellite and the Earth's surface is h. An extra height is there. We learned this yesterday. Because satellite is not revolving on the Earth's surface. It is outside. So basically an extra distance h is there. Which means if you consider the Earth's surface, sorry, the Earth's radius to be RE, the distance from the center of the Earth to the satellite is nothing but RE plus h. Yesterday's concept. So when you're trying to calculate orbital velocity, you will start off by calculating centripetal force given by the formula mv square by r. A small twist here. R is fine. But in this case, what's the total distance? R or R plus h? R plus h. So I'll add RE as it is plus h. Getting it? Because the satellite was placed somewhere outside. Because the satellite is revolving around the orbit, it's called as orbital velocity. How do we represent orbital velocity? Just put a O there. If you put a E, it's called escape speed or escape velocity. If you put a O, it's called as orbital velocity. I'll repeat this again. So this is the same diagram. Satellite was placed outside the Earth's surface, which means at an extra height h. So the total distance becomes RE plus h. The velocity with which it travels there is nothing but VO. Why O? Because it says orbital velocity. So we find what? We find the centripetal force first. Next, we also find the gravitational force. F is given by G M M by R square is the formula. But here, distance is not R. It is R plus H. So I go back, I change it. It becomes RE plus H the whole square. So equation number 1 gives me centripetal velocity, centripetal force. Equation number 2 gives me gravitational force. I know both of them. Okay. Now, how do we start? How do we continue to find the actual value of V thing? Whatever force, man, both the left-hand sides are same, no? Gravitational force or centripetal force, who cares? For me, it's nothing but some kind of force. So we start equating equation 1 and equation 2. Why? Left-hand sides are the same. So we always equate the right-hand sides. So it becomes mv naught square divided by RE plus H. Okay. Don't get confused. Centripetal velocity in the denominator does not have a square. Okay. Right side GMME divided by RE plus H. This has a whole square. Now see, what or not can get cancelled. I want the answer for V naught square. M got cancelled. RE plus H once and RE plus H once got cancelled. Left hand side V naught square remains. Right hand side G remains. ME remains. Whole thing divided by RE plus H. Only this remains. Okay. Now again I have square. I want only O. Take root. GME divided by RE plus H. Simple. Now the problem here is they'll again ask, this is in terms of caps G. What's the answer in terms of lowercase g? Same thing. Sin. Right? V naught is equal to root of. We know that RE is an is extra. I told you that extra thing will come where? In the numerator. So you write RE. Okay, you write RE. Now what did we want? We wanted G. We write that also. Copy paste the same denominator as it is. In fact, they won't ask this. Okay. Anyways, ignore. They won't. Okay, till here only you'll get the answer for definition. But by chance, okay, wait. Why am I teaching you so much like such a complicated way? In an easy way, I'll teach you. Same concept as I told you. V naught you write as it is, just like the previous thing I told you. No, like this I'll teach you. Okay, equals, right? root as it is. In the previous question, we had to write 2 because the 2 was extra. In this question, there's no number extra and all, so I won't add anything. Look at this thing. Look at this thing. RE is extra based on the form. Array. Based on the formula, RE is extra. What is extra? I mean, what we wanted the answer in terms of G. Therefore, the answer becomes root of GRE. That's all. Okay. Same thing like the previous question is just that ignore the 2 from there. That's all. Shortcut. Remember it. We'll get the answer full. Same. Okay. So today's class, all the derivations, again important, but this time it's important in terms of both, you know, um, CET perspective as well as this thing, with POC, MCQ also. I think I'll require one more class. Tomorrow's class, we'll finish off. A small part is left. Okay. I mean, this morning I saw it is, it was not the last year. I think this year we still do not have any idea with respect to it. So until then I'll have to teach you that. It is based on a little bit based on energy itself and a little bit based on numericals. Okay. So that tomorrow's class will finish it off. But make sure till today, I think we've solved around 6 to 7 derivations, including yesterday's class. Make sure you guys practice everything once. Once you guys are done with all these things. Fine. Because tomorrow's class, once I start with numericals, I'll be like orbital velocity in terms of lowercase g. What's the formula? You should be able to get this answer. Okay. See you.